Okay, that's nice. Okay.
So
So the
you
right?
clear about the doubt, right? So we can run the two different two commands in a single line by using and
Okay,
operator,
okay.
logical and.
Yeah, yeah, that's what I'm asking. Okay, thanks, Ravi.
Okay. So there are two more. There are two more topics are pending. So those are like achieving, how to achieve, and what is a small file problem, and so how we will solve the small file problem, and we'll see write flow and read flow, and yeah, those are the topics are pending. So we'll be completing today. Yeah. So then once we complete today, we will start Java by Monday morning. I mean Monday morning IST. It means our Sunday evening. Don't know, not it. Guys are not it. Join.
Tomorrow there's no class, Ravi.
Tomorrow. I think tomorrow means yours Saturday evening, right?
Yeah.
So there is no class.
Okay, okay.
And my Monday morning IST. That's your Sunday evening. We have a class.
Yeah. Okay, okay, okay. Okay.
This, I mean, we'll be completing hdfs. Okay, so I want you guys to do hands-on in at least in one day, and next day if anyone have any doubts or if anyone has any thing, we'll start. Yeah, I'll share Ravindra. I not started actually. I'm just waiting for the people. I think people, uh, most of them are not joined. Only four are there. Anyway, we'll continue with this, guys. I'm just checking. Okay, are you guys able to see my screen?
Yes, Ravi.
Yeah. So what is the small file problem? So, why Hadoop is meant for a large number of large files or small number of large files? Why it is not meant for large number of small files? Any reason, guys? Anyone wants to answer for this?
Hadoop is mainly to handle the huge data, huge volume of data. Am I correct?
Exactly. Yeah. So, when it's huge volume of data, I can say large number of small files. I can give a large number of small files, right?
Correct. Correct.
So, I mean, what is lacking here? So, could you please try to understand from the architecture level? Could you please, no, try to answer me? Yeah, I'll go ahead. So, Hadoop is meant for a large, where you say to store, manage, and process a large amount of the data. We know that HDFS is meant for that, and how it is maintaining. It's it how it is storing. It is storing data in the form of block structure file system. What is that? Block structure file system. Block structure file system means where the data will be stored in the form of blocks in multiple machines, right? And that metadata, that data about the data, where this data is stored, and who is responsible for this data, where and all it is, which file system it is stored, which data node is stored, this block is belongs to whom. All this information we called as a metadata. This information is maintaining by our name node, right? Here we are following master slave architecture. And who is the master? Name node. What is his responsibility? Maintaining the cluster, or maintaining the resources, or maintaining the metadata, and it means that data about the data, where the data is stored, and where in the sense here we have multiple mission, which mission it is stored, and this data belongs to which file, right? Maintaining the namespace. Ideally, it's maintaining namespace. If it is a small files, let's assume if it is a small file, even though it is a small or big file, it has to maintain. Let's assume, I'll just give a small example. I have a 2000 or two, let's take a small example. 200 1 KB files are there. 201 KB files are there. How many blocks will be created? How many blocks will be created? Bharat, Chandu,
200, 200 blocks.
200 blocks will be created. Even that is
Yeah.
1 KB, it will get created 200 blocks, right? It doesn't matter for it whether it is the file is 1 KB or 100 MB or 1 the file is a very small or big, but it will divide the file into blocks in the form of chunks where it is 64 MB, right? 64 MB is a block size. Doesn't mean that this 1 KB will store into the 64 MB and rest of the space will be wasted. It's not like that. But even though it is occupying 1 KB, but our Hadoop is treating it as a one block, right? But this block information has to maintain by name node. So it is a burden to the name node. Let's assume 200 files. If I have 2000 files, if I have 2 million files, if I have 2 billion files, it is a burden to my name node. Name node has to maintain all the block information. The clear, right? So if it is a 64 MB, if it is a 64 MB, all these 200 KB files can keep in one block, right? So I don't need to maintain multiple locations. I don't need to maintain multiple namespaces in my cluster. I mean, with respect to name node I'm talking, I don't need to maintain, right? So to avoid this problem, Hadoop come up with a feature called archive. Hadoop archive is called Hadoop archive. What it will do? We'll keep all these 200 files in one folder. Anyway, the files will be stored in under one folder. Either it's a data folder or some other folder. Whatever the files you want to archive, we will do as kind of a zipping. Zip all of them and store in the hdfs. What is the use of it? Even though all these 200 files, all these 201 KB files or 10 KB files will be zipped and it will be stored in one data node only, and it will be treated as one block only. We are reducing the namespace, or we are reducing the metadata information to maintain from the with respect to name node, and we are saving some space. But what is the problem? If I archive it while processing it, how it will treat? It has to unzip and process, or whether it can process it or not. But we can able to do it or not.
We can
Guys,
without unzip.
we will see
No,
that.
without.
Yeah, we'll see that, Zain. Okay, come to the part. I mean, I'll be sharing this document for you guys can get more information about it. In HDFS, each file stored in the block, and this block metadata held in the memory by name node. That's what we have discussed. No matter how small file is, the same method is followed for HDFS and have the storage the small file inefficiently. As a result, large number of small files can consume a lot of memory and the namespace. And hdfs provides a file or see the namespace, it is almost same, right? It is large block or small block namespace. In the namespace, it won't reduce the space in the name node. Like in the name node, whether it's a large file or small file, it has to maintain what it will maintain. Block 1. stored on data node 1, data node 2, data node 3, like that, right? And file 1 contains b1, b2, b3. This information never change, right? Only the thing is, if it's multiple blocks are there, I mean, anyway, it will take block 1 only. And how many duplicate blocks are there? This block 1 is stored in how many places? This information never change. Never change in the sense, the same. Almost same for the larger file or small file. Right? It will occupy the same space for the respective small file or bigger file. That's what it's trying to say here. That's what I'm trying to say here. Even the small file or bigger file, the consumption of memory in the name node is same. hdfs provides a file archive facility, a special format of archive. It is called HAR, Hadoop Archive. Okay, and it will store. Hadoop archives the store files in HDFS in the block more efficiently. It can be one block only. No need to be have multiple blocks, and it reduces the memory usage in the name node. Then fine. What is the point? As I explained in the example, in HDF, a small file do not take up any more disk space than its size. As I said, even if it is a 1 KB, it will occupy 1 KB only. It will not like it will take 64 MB and it will store only 1 KB in that, rest of the space will be wasted. No, it is not the case. Even though it is a 1 KB, it will take 1 KB size only. Rest of the space will be utilized for some other purpose. That's what here with an example we are specifying here. How to do that? How we can archive? How we'll do the archive? A Hadoop archive is created from a collection of files using archive tool. There is a command called archive. We'll see that. The tool runs a MapReduce job, ideally as like your distributed copy. If you remember, we have discussed about the distributed copy. DistTCP, it is called DistTCP. I'll be giving the notes for it as well. We can go ahead and look at what this DistTCP will do. Where you want to copy from two different locations in the same cluster, or it can be a different cluster. From this cluster, we can go ahead and store in this cluster. It's called distributed copy, where it launches the MapReduce jobs and it will just copy the data from this cluster to this cluster. Okay. For more details, I'm going to upload the document. You can go ahead and look at the document. Here also the DistTCP is launching MapReduce job. So idly map only job in the DistTCP. We will see that. But in archive, it is launching MapReduce job to process the input files in parallel. So in order to run it, we need a MapReduce cluster to use it. It means that when you want to run this archive, your job track and task track should run. We'll see that. A Hadoop archive maps to the file system directory. A Hadoop archive always, the extension will be .har. What it contains? After archiving, what it contains? It contains three different files. One is the index underscore index, another one is the underscore master index, and other one is part file. What is a part file? The part file is contains the part hyphen some 0 or part hyphen 1, it will shows. That part file actually contains the data. We will see that. We will do a hands-on. The Hadoop archive directory contains metadata and data file. Metadata in the form of this, and the index file contains name of the files that are part of the archive. What are the files comes under this? What are the files comes under this archive? Those files will be maintained by your index, and other one will contains the locations. The master index contains from where to start it'll till where it end the file 1. The file 2 from where it will start, from where it will end. File 3 from where it will start, from where it will end. that information maintained by your master index. We'll go ahead and see them, guys. Okay, so let me try an example from my cluster, from my setup. I'm archiving. Let's take, I would like to archive, let me see this, how many files are there? This only two. Two directories, but under the directory, so many folders are there again, and each folder contains again some data, and those small files actually. Those are small files. If you see, 2.34 KB. So that's, let me take. Yeah, let me do the same only. This one only. It has multiple folders and it has so much of data in that. Same same folder, different name. I'll do that. Archive to same folder. I'm trying to do. Command I'll be doing into this user location. What is the command? -p. It should be a parent directory also. We'll see that. Hadoop archive is the command, and -archive name is an attribute where you have to give an archive name, and your so -p is it's representing parent directory. If you want to give, you can give here slash user, and where you'll give the source and where you want to store source and destination. Okay, let's execute parent path. Let me see this parent path. I'm a little confused here. Why we need to? Okay, when it's a parent path, I don't think we should do this. Let me see this. No, I don't think this. Let's see. I think this parent path is expecting in the cluster where we'll give IP address and port number. But in our case, it's a local, right? So that is the reason it is the parent path is not required. Bharat, Chen, Jay, and Prabhu, are you guys able to follow me? What I'm trying to explain here? What is the purpose of the archive? Yeah. And see, if you observe here, it is launching MapReduce job. So mapper is 0% and reducer is 0%. It is starting, and it started and it's created the job ID also. It's created some job ID. This is the job, and it's launching the map job and reduce job. We'll see more details about this map job and reduce job when it comes to the map reduce part. I think it may take some few seconds. Map is 100% is done. Reduce is still 0. Yeah, map and reduce both are done. 100% 100%. Now here, if you see, these are called counters. These are called counters. We'll see in detail when it comes to the topic, like in map reduce. You can just on a high level, you can just see, try to see here. It is create a job, and it wants to map and reduce jobs, and how many reduced tasks is started here. You can see here. Okay, how many splits, small files, split files you can see, and if we see how much file it is read, I mean how much data it is read, ideally to process it. The file bytes, hdfs file read, file bytes written, some MapReduce framework is launched, and here number of mappers, the map input records, how many records went to the map function, this many, and how many went to reducer also we can see, this many. Okay, and we don't have any combiner here, we don't have any any partition or something. Map output records this, and your map output record or map reducer input record should match. If it is not matching, something went wrong. Okay, how much heap size is taken, this is high level, something we can at least understand from this log. It means that my job is success. Okay, let me go ahead and see, whether the archer has been created or not. Let me refresh this. Let me take where it has created archive 2. Under the archive 2, as I explained, success is a, it's not a part, it is a file which indicates your MapReduce job is success. It is not only for specific to archive. Any MapReduce job you run, you will get this underscore success file. If you have underscore success file, it means that your MapReduce job is success. Your index contains, as I explained. See here, if you see clearly, memory usage file directory, and this is the this is the number of bytes, and his user, his group belongs to, and this is the file it contains. Okay, and if you see vr metric state, and this is the file in that, it's a file, and setting update, some like that, media devices states, these are my file names, guys, and locations, and xms station change, screens transactions, these are the directories, and what this index represents, what it contains in your archive file, right? These many are there. So here you can see the dates. Okay, let's go back. Master index, I think it's not able to view here. We will see from the console. And your part file, finally, your part file, it is a compressed, we cannot view from directly, and we will view through a console. Why we were not able to view this? Clear, right? How to create a archive file? Yeah, see, if you see in this command, the first option after the archive name is the name of the archive. It is like .her, in our case archive2.her. The second one file is put from where to which file we have to take for archiving, and here's source, essentially it is source of the your structure, file structure, and your output in that. Tool access the multiple sources as a tree. You can give multiple sources. Space, you can give one more source. Space, one more source. Not only here, while putting and getting also, you can have multiple sources. Space and give one more source. Space and give one more source. Okay. And while creating directories also, you can go ahead and create multiple directories. The final argument is output directory. Okay. and it contains the index and master file and part file. What it contains, it has been detailedly explained here. The directory listing shows the HR file name of two index files and collection of part file. Part file actually contains the your data. A part file contains the content of the number of original files concatenated together. It has all the data will be concatenated and shown as a one file. But this information again will be maintained by index, and indexes make it possible to look up a part file that is the archived file content, as well as it is offset and length. From which offset it started, what is the length of that file? Let's assume that in my case screen transactions. When which from which offset it is started and till what is the length of it. So then according to that I can identify the file is what is the content of the screen transactions. All these details are hidden from the application. However, it's used HR user scheme or UR scheme. The scheme is an interact with the HR file system. Then we will see how to look at what are the files are there available in that. Okay, Hadoop fs -ls /user /archive 2.hr file. Yeah, see here. As shown, this archive contains hyphen index and hyphen master index hyphen part file, and we will see the content of this. Yes, we can go ahead and do the archive. We can, we can go ahead and archive the bigger files also. This is the data. It is compressed LZO format. Ideally should not compress because my setup has LZO compression. Maybe it is taken by default LZO compression. And you guys try never setup with the. You guys doesn't have LZO compression. I know that because when I see. Okay, okay, understood. My MapReduce job started compressing. I'll show you why it is. In my setup, if I go and show here, I have a LZO compression here. MapReduce map output compression codec. I have used LZO compression. That is the reason my output is compressed. My output is in the LZO format compression, and that is the reason we're not able to view the no output in proper format. what it's trying to say, hyphen file. Oh, in this version hyphen file is not supporting. Okay, the cat itself it will display the its cat itself will display the content, but my case why it is not displaying because of I'm using the LZO compression. In your case it will surely display the content of it. You guys can try it. Okay, because my setup as I shown you here, I'm using the LZO compression. The compression is true. Yes, my compression is enabled. It's true. And my compression is, what is the compression I'm using? LZO compression. Because of that, my output has been compressed. That is the reason here it is my output is compressed. This my output is compressed in the LZO format. In your case, it will not be because we are not using any compression format. And if you take any of my output also, it is compressed, LZO compressed, and the data is compressed. So that is the reason we are not able to view here. So you guys can try it. You guys can really look at the data. Okay, guys. Yeah. Now this document contains more details about the archive commands, and you can go ahead and have a look. I mean, this document is have the detailedly mentioned with the screenshots and all. You can see it will be very easy to understand. I'll be sharing this document, the same commands, but I have given them detailedly. Okay, clear, guys? Any doubt? And we will look at what are the limitations has with this archiving, Hadoop archive. As I said, creation of the archive, where will we create? Once it is stored in hdfs, on top of that only we can create. It means that for original file we need to occupy some space, and also for archive also we need to occupy some space. But later you can go ahead and remove them. You can go ahead and remove the original files. But it is one of the limitation where occupying two spaces for the same. That is one of the limitation. If you see here, creation of the archive file will create a copy of original files. So we need as so much disk space for original files, which is archiving also. We can delete the original files later point after the creation of the archive file to delete the disk space. That is one of the limitation. The other limitation is it is immutable. Immutable means it can change. Immutable means it cannot change. Once you create an archive, you cannot add new file into that. You cannot remove files from it. You cannot add new files to the archive, or you cannot remove a new files from the archive. Right? For that, what you have to do, you have to create a new archive file. It is it is immutable. Mutable means you can add and you can modify, you can remove, right? That is mutable. Well, we're looking in the Java there are two different mutable objects and immutable objects. We will have a look at that time. Okay. And HR file can be used as input to the MapReduce job. This is one of the uses, but it's also limitation. That whatever the we have archive, we can give it as input to the MapReduce jobs. But there is no archive aware input format. We don't have the special input format. But at this point, you might have confused what is the input format. We will see more detail what is the input format, how it will work in MapReduce. We will see that. That can pack multiple files into the single MapReduce script. There is no that kind of input format. So process a lot of small files. Even HR files require a lot of map tasks which are the inefficient. Here, all are small files because even while processing it also, it will take multiple mappers to launch. Multiple maps. For each small file, it will launch one map file. Map job, map task, I can say. Clear, guys, about archives? Are guys clear about archive? Any doubts?
Yeah.
It's clear. Okay. And also, Chandu, you asked me yesterday one doubt. Is there any configuration for the speculation, right? That's it. As I said, by default it will be there. By default it will be true. And if you want to go ahead and stop the if you want to go ahead and stop the configuration, I mean, if you want to go ahead and stop that speculation execution, I'll show you the command where you can go ahead and stop it. Let me go to, okay, I can show here. SRC map red vi maplet maplet-default XML file where let me search with speculative. Oh, sorry. Speculative execution. Maplet.maptasks.speculative execution. It is true. If true, then multiple instances of the same some tasks may execute in parallel when it is one job is not able to pick it up. Reduce task speculation. Yes, it is also true. Clear, right, Chandu? You have a two configuration by default is
But
not
in my
enabled.
case, speculative execution is in false in my the default .xml.
In your case, it is false.
Yeah,
No, it
I enabled it. I enabled it yesterday.
site.xml or default.xml. Mapper-site
Default
default.
mapper default .xml.
Is it? But it's my default XML, my default file only.
Yeah, I enabled it yesterday.
Okay.
Fine,
But
I understood.
okay, fine. Not I know even in the version also no, it won't be any. It won't be that case maybe. Have you done any time change? No.
No, no.
Okay. Fine. It's okay. By default it will be enabled. By default it will be enabled. So
Yeah.
this is the configuration for it. See here, if you enable and if you go ahead and edit here, if you change it, it will not reflect. If you want to enable or if you want to disable it, you have to write in your mapred-site.xml. If you go ahead and do some change here, it will not affect on your in the your case. If you want to do some any override or something, you have to do in your site.xml file only.
Okay.
If you go ahead and change here to from true to false, it will not affect. Whatever it says by default, it will take that only. Okay,
Okay.
fine. Now let's go ahead and have a look about read and write flow. Data read and write flow. Before going into this diagram, it has some comic. Even I have collected from some of one of the good posts I have seen. One of the book it seems. It's a blog I didn't remember. I will explain this in detail. Before going into that, let me take a clear picture of it, and I'll just give an introduction to this, and you'll understand.
Vira, I have a daughter.
Uh-huh. Go ahead, Chindu.
Yeah, speculative execution is in a mapper or in itself in a map reduce or in it will hive something.
Okay. See, it is these are the default configurations, right? Whenever
Yeah,
if you run our Hive or Pig HBase, what will happen at backend? It will be running MapReduce jobs only, right?
yeah.
If they want to launch the MapReduce jobs, they have to take care of these configurations, right? Understood what I'm trying to explain? When you
Yeah, I
launch
understood.
your Hive or Pig or these jobs at backend anyway, it will be again MapReduce. To launch our
Okay,
MapReduce jobs, which properties will read? These properties only. So it means that it will be
okay,
impact. It will be there, right? Not only for MapReduce, not only for the storing and processing the data. Whenever the MapReduce task is launched, this will go ahead and this part, the speculative execution will come into picture.
okay. Fine. Okay, got it.
Yeah. So this is the same what we have discussed before only. But before we have discussed high levelly, we will see in detail what is happening while storing the data into the cluster. We will see detail. That's called read flow and write flow. Reset is a name, no? We have seen this multiple times, but they will see in detail. Client, client machine. Ideally, it's a client machine. Name node and data node 1, data node 2, data node 3. There is an user or developer, and there is a file. Let's take EMP only. This has some data in it. Let's assume this file is 250, or we'll take it as a big file this time. File size is 1 GB. As we know that the configurations are like default configurations only. (64 MB). The block size is 64 MB.
16 blocks.
Yeah, replication is 3 only. Now a developer wants to store this file into hdfs. What he will do? First, he will enter the command in this command. He will talk to the client. In the client, he will give the path. What will say? Hadoop fs put and this file path he will do. He will give and he'll say that my file has to be stored in hdfs. What our client will do? Our client will divide a 64 divide this 1 GB file into 64 MB chunks. How many chunks will come? 16
16.
chunks. 16 chunks will come. We'll get 16 blocks. Let's assume them B1, B2, and so on, B16. 16 blocks are came. Then this client, it will pick the first block and he divided. Who is this client means? Wherever executing HDFS command, that guy only HDFS, that guy only client. And who will divide this block? We can say HDFS client.
Yeah,
HDFS client.
chunks is nothing but splits.
Block ideally
Vira.
we can talk it as a, we can call it as a blocks or physical split.
Okay, yeah.
And while coming to the MapReduce, we have a special term or specific term for MapReduce. It's called a split, or we can say it is an input split there. Okay, we'll see that in detail. We can say
Okay, fine.
physical split. We can say in MapReduce we can say that is input split. Here we can say physical split. Okay, this guy will pick block 1 and he will talk to the name node saying that I want to store some data into the cluster with these configurations. My block size is really doesn't matter for the block size for it, but still these configurations will be there, and he will say this is the replication factor. And when I take this block and when I talk to the name node, your name node will give will our name node is maintaining the metadata, right? Our name node is maintaining the more information about data nodes, right? Then it will give some of the data nodes to a client. Let's assume it is given dn2. Let's assume the dn2 is near to that, then dn1, then dn3, because it has to store 3 copies. Then your client will create a pipeline, data pipeline or pipeline with your data node, right? What it will do? It will start putting the first block, because for the first block he has given these many nodes. And how he will put the data into this? he'll put in the form of packets. That's the way we transfer the data into the network packets. Right? Packet is nothing but a small chunk, a small chunk. It is packet size is 64 KB. If you see our network, when you want to store some data through, when you want to pass some data through a network, what our client will do in the client server network, in the network ideally, your client will break the data again into pieces, small chunks, and the chunk will contain head and tail. Head information, tail information will be there. That's more into network theory. And we'll take it. Let's assume that our client is divided into packets. Then we'll start passing the packet, right? When it start passing the packet, first it will actually talk to the name node 2. It will not talk to the name node 1 because I have a diagram like this. Let's assume that this is name node 2, this is name node 1. Your client will talk to the first data node which is near to her, and that guy will start storing this packet, 64 MB packet. This packet, the 64 KB packet, will start storing in this. As soon as the packet comes here, the small packet comes here, he has to copy the replication, right? He has to copy the other replications, and also he'll be knowing that he'll be sending that what are the other replication factors and other replication data nodes. Then this guy will send the same packet here as well. And as soon as this guy get the packet, and he'll also send this packet here. For each packet, successful packet, this guy will send the acknowledgement, and this guy will send the acknowledgement, and this guy also will send the acknowledgement. So packet, it is ACK acknowledgement, and this is also acknowledgement. Acknowledgement contains a successfully stored or failed. What is acknowledgement? It will give whether I got the data. So kind of acknowledgement. We will say acknowledgement. Like that, it will copy all the other packets, all complete packets. Let's assume, guys, we are taking the successful scenario. We'll see the failure scenarios also. Okay. Once the data is stored, complete block is stored here, and these guys will start informing to, it's ideal like b1 here only. So for understanding, we used to take b11 or like that, right? But the block name is same always. If you remember, when you generate the report, it was showing that blk and the score some number, right? How the block name was there in the, when you generate the report, and this guy some xyz, some number was there here, right? The same block name will be like this only for all the data nodes. Once these guys start store, and these guys will inform to, we have stored successfully this block. All these guys will inform to name node. Then your name node will maintain information such a way that b1 belongs to, is stored in name node 1, name node 2, name node 3. It will maintain like this. And this then file, which file is belongs to which blocks and all, it will be stored once all the blocks are successfully stored, and it will take this file stored. This file has the block 1, block 2, and so on, block 16. Okay. Block to data node, file to block to data node, it will maintain that information. Your name node will maintain that information. Clear, guys, about this? Clear about this process?
Yeah, clear.
Okay. Now let's go ahead and look at the uh, this PPT, the slides. Here, this PPT is representing some no by using some comic symbols to understand easily. And here, this guy is the client who is in pink color, and who are in yellow color is a name node, and these other three colors are the flat. It looks like a disc. It looks like a disc. Those are the data nodes. Okay, and this is a developer, or let's assume a user. Okay, this guy wants to store a file, 200 MB file, into a hdfs cluster. And what this guy is doing, this guy said that I want to store this into this guy. And when you configure it, this guy will be knowing that what is the configurations, what is my block size, and what is my replication factor. And when this guy will store that, he will be knowing that what is the replication factor and what is the block size. And this guy will start chunking. But here in the diagram saying that yes, the replication divided to 128 MB blocks and copy the three places. But ideally, that information we will not explicitly say, or you can say that also explicitly by using -d command. We will see that as well. And this guy will be knowing that, and he will. A good client always knows these things. Always he know it. We don't need to explicitly say that. When we say explicitly, it is belongs to that file. Okay, and he will break. Your client will break whole data into chunks, and he will get the blocks. And your data node, sorry, your client will talk to the name node. Let's work on the first block first. Mr. Name node, please help me to write this block here. 128 block we have taken. It can be 64 MB. I want to store in three places. This is the block, and this is the size of the block, and this is what I want to store in your network. Then replication factor 3. Okay. So the name node assumes that I have to give three different nodes. And how do I do that? How do the name node will do? The name node is maintaining. It knows it, right? The name node has more detail about the data nodes. Then it will give these are the data node 1, data node 2, data node 3. For example, they have given this format. Can be any data node 2 or data node 3 can come first, data node 1 comes. Depends on the policy. The which is near the client is very near to which data nodes, and which data node has a space, and which data nodes are the free, they're not processing anything right now. So these things will be considered by your name node, and your name node will give these things, and your client will start storing the data. I send my data to a listed data and first data node only. First data node only it will send. It will not send to the all the data node at a time. It will create a pipeline to the first data node, and he will start storing the data. Once he starts storing the data, parallelly he will copy into other guys. Okay. While I am receiving the data, I forward the same data to the next data node. Okay. This guy also will start the replication. So this is the way the replication data will be stored. Okay. And once they're successfully stored, and they will start informing to the name node, saying that we have done, yes, we got this block, this block, this block. And your your name node will update these details into its metastore. When I'm done with the block, I repeat the same with all the other steps with the same block. Once all the data is stored successfully, it will remove the pipeline. The data pipeline. So when all the blocks are written, please close this pipeline. Again, it will tell to the data node saying that please close it. I don't want to continue. Again, done. My job is done. Now I store the meta information presented in the storage. In this, it's persistent storage. Ideally, it's a local hard disk like your Redis and FS image where it will come, right? The Redis. It is done that. And so just recap. What he has done, the client is divided the blocks, and he talked to their name node saying that I want to store this data into blocks, and your name node is given the blocks, and your data node stored the data into the blocks. This is what happened. Let's see if something went wrong in the failure scenarios. That is written. We have written the data into the cluster. How we'll read, and while reading only, we'll see the parallelly the failure case scenarios. What this guy is trying now. So the client, the end user, I want to say, I want to read this file, some XYZ, or in our case, employee file. Then he'll give the file again. He'll talk to the name node saying that this is the file I want to read. And when he give the file name to the your name node, he knows it where this data is stored. The file is the file has been divided with how many blocks. Those blocks are where and are stored. He'll be knowing it. Your name node will be knowing that by referring his metastore or by referring his registry. I will get the all of them. So he will give the block details to your client in the sense our HDFS client. Our HDFS client will start downloading the data from one of the block, one of the data node which is near to the client. He will connect to that data node and it will start downloading the data. It is like a Hadoop fs hyphen get command. Okay, this is like a Hadoop fs get command. So how we will do? He will start download those blocks. Here, see what happened while downloading, or some of the data node is failed while downloading, or while he has given the data nodes while interacting with him, he's failed, he's not reachable. How it will have been handled, we'll see here. While writing, if it is failed, what will happen? While reading, if it's failed, what will happen? We'll see. As I mentioned earlier, the client will divide data into small pieces, right? The small pieces of data it can pass through a network, and it will be passing. And all are passing, they will start sending the acknowledgements, right? They'll all acknowledge to your client saying that they have success. While storing, one of the data node is failed. What will happen? It will store successfully because the replication factor is 3. One data node is failed. Fine, let it go down, because anyway two copies are stored. Two copies are stored, right? So when these two copies are stored, what will happen? Supposed to copy 3 copies, store 2 copies. That is called under replica. So that will take care of your name node later point of time. But at the right time, in the current situation, yes, I am able to store to at least 2 blocks, because my minimum replication factor is 1. So at least 1 copy I should store, but I have stored 2 copies. Fine, well and good. So job is success, right? If it's failed while reading, we'll see that. Remember, when I asked for the location of the block, the name node give me locations of all data nodes. Like 3 data nodes it will give. If one data node is dead, I read from the other data node. This is that much smart enough. It will connect to other data node and get download the data. Okay. So what he will do, he will maintaining the your name node will be maintaining the registry, right? Which block is belongs to which file, which block is stored in what are the data nodes, right? So what he will do, he'll keep updating his metastore. His registry will be keep updating. Let's see here. I continuously update these two tables. If I find a block on data node is corrupted, I update first the table by removing the data node from the table. Let's assume the data block 1 is stored in data node 1, data node 3, and data node 3 has corrupted or is failed. What it will do? It will remove from here. And if I find that data node has dead, I update both the tables. And under replicable case, again, when it goes for the block scanning and all, when you execute the rebalancing command, that will taken care by our name node. For all under replicator blocks, I ask her to data nodes to copy. So as I said, when you added a new block, or when you added the same cluster only, we are able to balance it. Our name node will ask one of the data node to copy the data from other data node. It will start copy from there. Clear, guys? Yeah. So
Okay. Yeah.
go ahead, Chandu. I think Chandu, you're asking something.
Repeat the fault tolerance.
Okay. You want the fault tolerance. Okay.
Yeah.
So while reading or while writing?
Both in both cases.
Okay, in both the cases. Sorry. Let me explain with. See here. While writing, our name node will give a blocks. Data node 1, data node 2, data node 3. It will give the blocks, right? And while storing, in between something happened, the data node 2 is failed. Data node 2 is failed. Your data, when it's first to connect to your data node 2, and it is start writing the data, right? Let's assume that this is data node 1 and your data node 1 is failed. This is failed. what it will do, when it talk to this guy is not responding to your data node, then your data node will directly talk to the other data node, and you'll start put the data in that. So that case, how many blocks will be stored? The same block will be stored twice only. Instead of thrice, it will store only twice, right? So
Okay,
now
that 1 second, sorry. That corrupted data node second will be created by name node, or after that.
created means I didn't get you, Chandu. See,
It means
initially when it is giving the data node list, it was success. It was giving the heartbeat. It was giving the
yeah.
heartbeat to the your name node. So the time when it says that name node was success, I mean name node feel that it is alive. Okay.
Okay.
When your client is start storing the data, when your client starts storing the data into the cluster, that time your no your name node will talk, your data node will talk, name node will not come into picture here. Now your data node
Yeah.
will talk to this data node.
Okay.
Hey, I have to store some packets of data in your no hard disk, please respond. So that time if it is respond, okay, it says that okay, both are it's working fine, then we'll start sharing the data. If it is not responding when it's talked to the data node, then it is a dead, right? It is failed. So that time our data node too, I mean what is the data node which has to copy, the data node will not talk to that. So it will just skip that and it will go ahead and talk to the other data node.
Okay.
I think still you have a doubt.
No, no, no.
It's clear.
Clear.
Okay, now in this case what will happen, the data will be there in under replica. The under replica case will anyway will taken care by our name node the later point of time. So under replica, like we have only two or 10 data nodes. Let's assume that when we run the block scan, it found that it's under replica. This blk is under replica, and this when it's this block is under replica, what will do when we run a rebalancing command, hdfs hadoop dfs admin and rebalancing, what will happen, it will balance the data, and that time your name node will ask one of the data node to copy data from other node, then it will start copy and it will make it the balancing. We have discussed about the under replica, I hope, right? So let's assume that there is one more data node, and when this rebalancing, it found that one block is under replica, then it will seize that which is near to this data node, which is the near data node, whether that data node has the block or not. Yes, it has a block. Then it will say to this guy dn4, uh, please you copy this block b1 from the data node 3. Then we start copy here. Then it will balance the data.
Who will balance this? That client will balance those data nodes.
No, client will not balance. Our name node will tell to the data nodes to copy the data.
Okay, okay, okay.
Client will not come into picture here. This is now out of the client. Client is not there in this case. So only cluster itself
Okay,
is managing internally.
okay. Got
Okay.
it.
Yeah. This is a failure while writing the data. While reading also,
Writing.
while reading, the client will give the file name to the name node. I want to
Okay,
I want to get download this file, and your name node
okay,
has the list. This file is belongs to these many blocks, and these blocks are stored in these data nodes, and it will give the list of the data nodes to the client.
okay,
It will give the list of the data nodes to the client. The client will talk to one of the data node to download the data. Let's assume
okay,
that data node is failed. Anyway, even though it is
okay.
failed, it has other two data nodes, right? Because it has a three
Yeah.
replication. Then
Replication.
it will start. It will connect to other data node. It will start downloading the data. Clear?
Yeah, clear.
Okay. So any other doubts, guys? So we have completed hdfs successfully, and if any small topics are missing, we'll cover no, when it comes, like sometimes while processing MapReduce also we may come across one of the hdfs related concept kind of thing. That time we'll go ahead and expand them in detail. Any doubts? So I'll be ending up the session, and if you guys have any doubts, please ask me. and I'll go ahead and answer.